Greetings from Microwaves 101. Today we're going to do some temperature measurements out here in the environmental lab. Nice lab coat. Here we've got a temperature chamber. And let's open it up. There's some unknown hardware in there with a lot of semi-rigid cables. Nice thermocouple attached to our unknown module. And it's got the elderly labels so that anybody of advanced age can read them. And we come out here and we've got a PNAX to do measurements. There's no switch matrix. A switch matrix is someone with a wrench moving the cables around. So we're going to take data at 3 temperatures. What happens to the loss of the cables over temperature? Of course it changes. So when it gets hot, the loss goes up. When it gets cold, the loss goes down. This is complicated by the fact that some of the cables are outside of the oven. Some of them are inside. Those are 3-foot cables. There's approximately 1 foot in the oven. They're all pretty close to the same length outside of the oven. So we're just going to pick a pair of them and then do a calibration over temperature. The calibration over temperature, sorry to get you dizzy here, is to go in here, pick 2 of them, put that bullet in between, measure it over temperature, give it a nice soak so it stays at the temperature. Then we come back over here to the old microwave office. And of course we're going to model this. We have a transmission line model of the cable where some of the cable has a temperature coefficient that's outside of the oven, some of it's inside. And I can vary the length of the cable that's outside of the oven. And then I put that into a back-to-back cable model. There's 2 of those back-to-back. And I plotted it against the measured data. And let's just zoom in here a little. You can see that the measured and the model are lying on top of each other. There's some disagreement where the back-to-back cables have an ugly VSWR. But on the whole, it's a pretty good approximation. So going back to our cable model, it seems to fit that we have 100 millimeters inside the oven, which doesn't make a lot of sense. There's more like 8 inches. That's only 4 inches, but we don't care. The model fits the data. We're going to go ahead. Thanks. Have a good one.